Okay, so we're going to be reviewing for test one, and you'll notice I have part two because I did the first half of the review for my 8 o'clock class, and I'm going to post a link to that video once I get it uploaded after class today. So be looking for that email so you can catch the second, the first part. So we got through the first 47 problems out of 100 on the review. So let's just continue with that. Number 48, we're asked to state the average rate of change for the situation and be sure to include the units. So the situation is that the temperature rose from 69 degrees at 5 p.m. to 75 degrees at 7 p.m. And when you're calculating the average rate of change, you're just calculating the slope for a function between 2 points. Okay, that's all the average rate of change. So for example, let me copy this information real quick. 69 to 75, and then 5. So here's our situation. The temperature rose from 69 degrees to 75 degrees. And when you hear the word rose, that's a vertical movement, right? It increased upward. So think of that is the temperature is dependent on the time, and therefore the temperature is the y-axis and the time is on the x-axis. So when you're calculating the slope, so the average rate of change, is the rise over the run. And so it's the rise in temperature over time period. Okay, and so the units are going to be degrees per hour or time or seconds, whatever the units are, probably per hour. And so the change, you're going from 69 to 75. So that's going to be 75 degrees minus 69 degrees. And then you're going to divide that by from 5 to 7. So it's going to be 7 minus 5. And so this is in hours. And this is in degrees, obviously. So the units are going to be degrees per hour. Okay, those are the units. So 75 minus 69 is going to be 6 degrees. And then, so it's 3 degrees per hour. And if the temperature had been decreasing, it's still considered a rise. It's just that it's negative because you're going down. So, if it had gone from 75 to 69, then it would have been going down. And so we would have gotten -3. So it just depends on, which direction it's moving. So the temperature rose 3 degrees per hour. So if you had selected degrees, that would have been incorrect. Because the rate of change is always going to have a numerator and a denominator in the units, because that's how it's calculated, rise over run. Okay. So all of these questions are like this. State the average rate of change. Sorry, I forgot to turn my phone off. Okay. So he delivered 27 packages in 3 hours. So the rate of change would be 27. That's the rise, the numerator. and then divided by 3. So it'd be 9 packages per hour. So you can see how these problems work. You just have to calculate. Oh, I wonder if that's my husband. We share a phone, and so he has to authenticate with using my phone. That's what it is. Okay. Okay, so here you've got population growing, and it's going from 2,500 to 2,700. So it's 200. That's a difference of 200 in 2 years. So that's going to be 100 per year. What? Oh, you're right. Sorry. I don't know why I looked at that wrong. So let's see. So that's over a period of 8 years, 200. Let me just do this. I don't know if they want a decimal or a fraction. I think they want a fraction. So $25 actually is what it is. Okay, there we go. So you get the feel for these. I don't want to go through all of them just to save time. So this is how, but that's how you do these type of problems. Let's see, they're all pretty much the same thing. Okay, this is the difference quotient. You should be able to calculate the difference quotient for any function. Let me just show you how to do that, or remind you how to do that. So we have f of x plus h, and then minus f of x over h. And our function in this example is f of x equals x squared. And I think I actually did this very problem in class. So you're going to take whatever your input is. In this case, it's x plus h, and you're going to square it. So instead of x squared, we have x plus h squared. And then we're going to subtract our f of x, which is x squared. And so then remember, you have to FOIL it. When you have a binomial like this squared, you have to FOIL it. So it's going to be x squared plus 2xh plus h squared. You're subtracting x squared. And the trick with these problems is you're always going to end up with h in your term. So if anything that doesn't have an h in it has to cancel, otherwise you did something wrong. But here we have x squared minus x squared. So everything is left with h. We can factor the h out, and that gives us 2x plus h times h divided by h. That's going to cancel. And so this is the difference quotient. And then you can go ahead and fill in the table values based on what your difference quotient is. So if you look here at the table values, you just plug in, you're doing 2x plus h. So 2 times 5 plus 2, that's 12, 2 times 5 plus 1, etc. You just plug in the values. So those are pretty straightforward. Same thing here. The difference is that you have a different function. But again, you just plug x plus h in, square it, multiply it by -2, subtract -2x squared, divide everything by h, and there you have it. So just practice those. There's, yes. Right. Yeah, thanks for bringing that up. It's Tuesday, and we're not going to meet here in the classroom. We're going to meet upstairs in room 3000. You have a computer. You have to use their virtual calculator on the computer. So don't bring your own calculator, because I'll ask you to put it away. And so you might want to stop by there. Someone pointed out to me last period that Monday is a holiday, so it won't be open. So you've got to, today or tomorrow is your last chance to check it out if you want to do it before the test. Unless you can, yeah, because probably, yeah, it won't be open at 8 on Tuesday. So you have to do it either today or tomorrow. It closes at 5 p.m. today, and tomorrow it closes at 2 p.m. So let's see here. Okay, there is a question like this on the test, so make sure you know how to do these. You have to find the equation of a tangent line to the graph. So you're given a function, f of x equals x cubed, and you're given a point, -2, -8. And this point, by the way, you'll see lies on this curve. So if I plug in x equal -2 and cube it, that's equal to -8. So therefore, this point is part of the curve. It has to be, because if you have a tangent line, it touches the graph at that point. So we want to find the equation of the tangent line. So just as a little diagram here, you have a point on your curve. I'm not saying that the curve looks like this, but the tangent passes through that point. Okay, so we're going to be looking for an equation y equals mx plus b. And m is the slope of the tangent at the point -2, -8. So really, when we see the word at, we're thinking of x equal -2. Okay, and then b is found from the slope and the point. You can calculate what b is. So let's start with m. Well, the whole idea of a tangent line is that the derivative is the slope of the tangent at x equal -2. So the derivative, this is what the whole problem rests on. The derivative is the slope of the tangent at x equals -2. So we just have to calculate the derivative. In other words, f prime of -2. So f prime of x, this is a power function, so we're going to use the power rule. We bring the 3 out front, and then we subtract 1 from the exponent, so it's 3x squared. And then to calculate f prime at -2, we plug in the -2 and 3 multiplied by 3 after we square it, we get 3 times 4, which is 12. So this is the slope of our tangent line. Okay. Now that we found the slope, we can go ahead and plug in the information. X equals -2, y equals -8, and b, we're going to, after we plug in the slope, we're going to calculate b. So we have -8, I'll just write y equals mx plus b. So -8, that's the y value. The slope we found to be 12, so I plug that in. And then the x value is -2. And from that, I can calculate b. So solving for b, I have -8 equals -24 plus b. I like to use different colors. Hold on. So I add 24 to both sides of my equation. So b is equal to 16. So our tangent line is y equals 12x plus 16. So that's my tangent line. And all of the problems like this have the same, you solve them the same way. So just practice that. I know there's at least, I think there's at least 2 problems like this. I'm pretty sure, maybe 1 or 2. So just practice that. There are a lot of problems in the review that you can practice. Any questions on that problem? So here, this is the same sort of problem that you will encounter. Differentiability. This particular problem is kind of out of order because of the way these homeworks get set up. They separate the multiple choice questions from the regular questions, and so it causes them to be out of order a little bit. But we'll just go ahead and talk about differentiability now, and we'll come back to it as we do more problems later. So differentiability. Now, I talked about continuity in my last class period, so make sure you check out that video if you forget what continuity is, but I'll just give you a little refresher. Continuity, basically, if you can draw the function without lifting your pencil, it's continuous. So we can see from this graph here that we can't draw it completely without lifting our pencil. Now, differentiability, in order for a function to be differentiable, it has to be continuous. So if it fails continuity, then it's going to fail differentiability. So you can see it cannot be differentiable at this spot where there's a hole or where there's a break. So anywhere there's a hole or where there's a break, it's not differentiable. But differentiability is stronger than, the idea is stronger than continuity, because in addition to having no breaks, you can't have any sharp points or corners. And you can see right here, this spot has a sharp point. So differentiability measures how smooth a function is, how smooth the curve is. If there's a sharp corner or point, it's not differentiable at that spot. Now, when you're asking where is it differentiable or where is it continuous, you're looking at the x-axis. Whenever you're trying to answer a question about where something happens, it's always at the x-axis. So to answer this question, it says where it's not differentiable, right here, what is the x value at that spot? Well, you draw a vertical line down to the x-axis and it's at 1. And here there's a hole. What is at the x value at that spot? If you draw it down, you'll see we're at 3. So, and then here, if you draw a vertical line, there's a break. If you draw a vertical line, you're at 5. So when you answer the question, where or is it not differentiable? It's at 1, 3, and 5. Okay, so that's how that works. Notice they say x equals 1, 3, 5. Okay. So it says here, list the points in the graph at which the function is not differentiable. Okay. Again, it has to have no breaks or holes and no sharp points or corners in order for it to be differentiable. So here, this is perfectly smooth and connected. That's fine. And right here, perfectly smooth and connected. So that's fine. Everything else, there's either a break or a hole or a sharp point. So at those places, it's not differentiable. I think I've done this one in class. I'm not gonna take the time to fill it out, but that's the idea there. Then tangent lines cannot cross. They just measure the slope of the curve at a point. So these two right here and here cross. And so those are not tangent lines. Everything else is just touching or showing the slope of the curve at that point. So L1 and L5 fail they're not tangent. Okay, there are a lot of questions, not a whole lot, but a significant number, because section 1.5, we learned how to calculate derivatives using the constant rules. There are 2 of them. The sum and difference rule and the power rule. There are 5 basic derivative rules that we have covered so far. So you want to be able to use them. I'll never ask you, what is this rule, but you want to be able to use them. So let me just work through some of these examples here. Here we have f of x equals x to the 9th power. And this is problem 62. And it just says find the derivative. So to find the derivative, you're going to apply the power rule, take the power, multiply it out front. And then you subtract 1 from the power. 9 minus 1 is 8. So the derivative, and that's the power rule. Okay. So here we're given y equals 11x. This is a linear function. You see this, the slope is 11. And so, and you can apply the power rule. The power on x is 1. 1 times 11 is 11. And then when you subtract 1 from the power of 1, you get x to the 0. Well, that's just 1. So you don't have to write x to the 0. It's just 11. But I always tell people, if you have a linear function, the derivative is always its slope. So the slope here is 11. So here we have a constant. The derivative of a constant is always 0. So if there's no variable in your function like this, there's no x, you know that the derivative is going to be 0. So these are really easy to do, but you have to know the rules. So make sure you practice. Here, don't be bothered by the negative. We have y equals, what's it, x to the negative 7? Is that what it said? I forget. Sorry. Yeah. Okay, so we have y equals x to the negative 7. It doesn't matter the negative, the power rule is the same. You take the power, and so dy dx is negative 7. You multiply that out front, and then you subtract 1 from the power. So negative 7 minus 1 is negative 8. And that's the derivative for that. Okay, now we can apply the sum and difference rule in conjunction with the power rule here, because we have several terms with x's with different powers, but they're added and subtracted. Okay, so let me just copy this real quick and then I'll go do this problem. Okay, so again, you're going to, somebody asked me yesterday about the sum and difference rule and like, how does it work? Well, it's kind of an intuitive thing. You're not going to be thinking about, oh, I'm using the sum and difference now. It's just, you just are allowed to calculate the derivative of the entire polynomial by piecing it separate or taking each piece separately. That's what the sum and difference rule allow you to do. So that's what I'm going to do. 3 times 4 is 12x, subtract 1 from 3, I get 2. Then the next term, 2 times negative 8 is minus 16, subtract 1 from 2, I get 1. I'm not going to write 1, but, and then this takes us to the linear part. Of course, the derivative of a constant is 0, and here's the linear term. The derivative is the slope, 21. Okay, so that's the derivative. Any questions on that one? So just practice these. They're pretty quick and easy to do, but you will want to know the rules. Now, don't be troubled by a square root. You just want to write it as a power, because remember, the only really substantive rule that we've learned is the power rule. So all of these problems, you've got to convert everything into a power. And this we have here, let's see, y equals 2 square root of x. And it's important to note that square root of x is equal to x to the 1/2. Okay. So if you don't know, or if you're not comfortable with rational exponents like this, go back to the review. There was an assignment at the beginning of the semester that covers that. And in fact, in my YouTube playlist, there's a spot where I talk about rational exponents. So if that's something, make sure you review that. So the derivative, since this is written with x to the 1/2, we just take 1/2 times 2, which is 1, and then, so I'll just write it here kind of to show that's where I got that 1 from. And then 1/2 minus 1 is going to be x to the negative 1/2. And you can write that as 1 over square root of x. The negative just indicates that you take the reciprocal, and the 1/2 is the square root. And there are a lot of different ways you can write this, but they're pretty lenient. So for example, I think I can just take x to the power of negative 1/2. I don't have to simplify it necessarily. Okay, it should be allowed to do that. And decimals are okay. You just take the decimal out front, so it becomes 0.7, and then you're going to subtract 1 from 0.7, so it's going to be raised to the power of negative 0.3, because I'm subtracting the 1. Like that. Here again, don't be bothered by the decimals or the fractions. Just 1/2 of negative 2.8 is going to be negative 1.4. And then you subtract 1 from 1/2, that gives you negative 1/2. And so you can see how quickly we can do these problems. Okay, now this one, again, don't be bothered by the fact that that's in the denominator. You can convert that. You always want to get the x's out of the denominator. So let me copy this and then I'll do this problem to show you how to do that. Okay, so we have negative 10 over x to the 5th. This, you want to think of this as negative 10 times x to the negative 5. Whenever you have a power of x in the denominator and you want to move it to the numerator, your sign on the power changes to negative. If it's positive, if it's negative, changes to positive. It just changes the sign. So because we got this x to the 5th out of the denominator, we have to write it with a negative 5 like that. And now we can go ahead and take the derivative. So y prime equals negative 5 times negative 10, that's going to be 50. And then I subtract 1 from the negative 5 and I get negative 6. So it's 50 times x to the negative 6. Same thing here. You want to, now be careful. This is a little tricky. The 7/3 is a constant. And so you want to write it as a constant multiple. So let me go ahead and work through this one. So we have f of x equals 7 divided by 3x cubed. The way you want to think of this is your constant in front is 7/3. And then you're multiplying by 1 over x cubed. Well, you don't want your power on x to be in the denominator, so you want to write this as 7/3 x to the negative 3. See, the exponent becomes negative when I move it to the numerator. Okay. So one mistake that students might make is they'll move the 3 with the x into the numerator, but you can't do that. The 3 has to stay there. Okay, so it's 7/3 x to the negative 3. Now we can go ahead and take the derivative, and it becomes negative 3 out front times 7/3, and then we subtract 1 from negative 3 to get negative 4th. The 3's, of course, cancel, and we get negative 7x to the negative 4th. Interruptions today. This is my daughter. Maybe emergency. Hey, did you know I'm in class? Oh, I just wasn't sure if it was an emergency or not, so. Okay, bye. We have a lot of little kids at home and stuff, so you just want to check and make sure there's nothing going, you know. Okay. Let's see what our next problem is. Any questions so far about the test or anything? Most of it's multiple choice, but there are a few. I guess it's a pretty good mix, half and half, maybe. So this is, what did I say it was? Negative 7. 7 times x to the negative 4. Okay. This one always throws people off, so let me work through this one. I think there might even be a problem like this on the test. I'm not sure, but I have been known to put this on the test, so I'll go through it. What's going on here? Well, this doesn't look like it, but it's just a linear function. So think of it as 1/9, right? Think of this as a 1. 1 divided by 9 is 1/9 times x. Notice x is in the numerator, so we just write x. Here, however, x is in the denominator, so it's -9. And I want to take x out of the denominator. The power on x here is understood to be 1. So when I move it out of the denominator, it becomes x to the negative 1. So this is the way I want to think of it. Now that it's in the proper form, I can apply the power rule. Here, this is a linear function. So the derivative is just 1/9. And then here we take -1 times -9, that becomes a +9. And then we subtract 1 from -1, and that becomes -2. So this is our derivative. When you're evaluating a derivative at a number like 1 here, you just calculate the derivative and then you plug in the 1. That's all you're doing. So here we have f of x is equal to 4x squared minus 4x plus 8. So when I calculate the derivative, I'm going to apply the power rule, and I get 2 times 4 is 8. Subtract 1 from 2, that's just 1. This is the linear minus 4, and of course that's a constant, so the derivative is 0. And I wanted to evaluate it at, what was it? 1. So f prime of 1 is 8 times 1 minus 4. I just take that 1, plug it in for x, and I get 4. This just means that at the point when x equals 1, the slope of the tangent is 4. That's all that means. I really encourage you to go through these problems on your own. Make sure you can do them. And then if you get stuck, then you can go back to the videos and see the example. But make sure you can do them on your own, because it's one thing if you sit here and watch me do the problems and you think, oh yeah, I get that. I'm ready for the test. It doesn't quite work that way. You have to do the problem. So make sure you get in there and do this review on your own. But if you do get stuck, the video is going to be available to you. So now we're getting into the batch of questions about continuity. And a lot of these are just graphs. So all you have to do is ask yourself, can I draw this without lifting my pencil? And the answer is no. There's a break right here. So this is not continuous. So it's that simple. These problems are really not that hard. Here, you can obviously draw it. So yes, it's continuous. But remember I said, and I'm just throwing this as a bonus, this is not part of the question, but differentiability. Is it differentiable? It's not completely differentiable because look at this spot, there's a corner there. So yes, it's continuous, but at this particular spot, there's a corner, so it's not differentiable there. But that's a differentiability question, but I'm just throwing that in there. Here, obviously, there's a break right at x equals 0, so it's not continuous. When it asks, is it continuous over an interval versus at a point, the interval means across the whole thing, but at a point means, so for example, this is not continuous over the interval because all it takes is one spot for it to fail. And if you want to say, where does that break occur? You can say it's not continuous at 0. And whenever you're asking, where is it not continuous, you're looking for an x value. So here's where the break occurs, and the x value at that spot is 0. So that's not continuous at 0, and therefore it's not continuous over the whole thing. So, yes, it's continuous, not differentiable though at these spots. At -1 and 1, it's not differentiable, but they're just asking about continuity. So yes, you can draw it without lifting your pencil. Again, here you can draw it without lifting your pencil, but here it's not differentiable and here it's not differentiable, but it is continuous. So differentiability requires continuity and it has to be smooth. Is F continuous? Now, in the previous questions, they were asking, is it continuous over the interval? Well, now they're saying, is it continuous at a specific point? And if we look at when x equals 1, here we are on the x-axis, there's x equal 1. Right there, there's a break. So no, it's not continuous at that point. It's continuous at the other points, but not at that one. And here at 1, no, it's not continuous. Again, if you find 1 there, there's a break. So no, it's not continuous. At x equal 2, here we are at x equal 2. Yes, it's continuous. There's no break or hole there. And it's actually differentiable also because it's smooth at that spot. So yes, it's continuous there at x equal 2. -1, here's -1. Even though there's a break at 0, they're not asking over the whole interval. They're just asking at -1. And if you go to -1, right here on the x-axis, there's no hole at this spot. There's no hole. It's smooth, so it's continuous and it's differentiable at -1. So yes. So be careful. If you look at it, there's a break. So the function is not continuous over the interval from -5 to 5. If you scan the whole interval, it's not continuous because of that break. But this question is asking only about this spot, -1. So if you go there, it's fine. There's no break there. So just be careful about, is it asking you over an interval or is it asking you at a point? Those are like little details that you want to make sure that you understand that. So here it's not continuous at 1 because at 1 there's a break. Okay. I think I'll just skip over the rest of these because they're pretty much the same thing. Okay, back to average rate of change. So here's a problem. The graph shows the total sales in thousands of dollars from the distribution of X thousand catalogs. Find the average rate of change of sales with respect to the number of catalogs. So again, average rate of change is rise over run. It's the slope of the line between 2 points. So the 2 points that we're looking are from 10 to 30. So here's 10. And if I go up to the point on the graph, it's 1040. So for that one, the Y value is 40. And then as you travel over to 30, here at 30, you're going to be up at 60. So from 40 to 60, that's the rise. So that's 20. And then from 10 to 30 is also, that's the run. That's also rise over the run is 20 divided by 20. So it's 1. Okay, see how that works? Similar one here, we're looking from 10 to 50. So here's 10, and I'm running along the x-axis to 50. That's a difference of 50. So the denominator is going to be 50. But if you look at the point you're going from this point to this point, and the rise is from 10 to 70. So that's going to be, let's see, let me make sure I got that right. From 10 to 50. So 50, did I say 50? I meant 50 minus 10 is the run. So that's 40. And then, so you start at 10, you go 1, 2, 3, 4, that's 4 tenths. And that's of course 50 minus 10 is 40. And then you're going from this spot here at 10 to this spot at 50. And you're going from 40 to 70. So that's 70 minus 40 is 30. So you're going to have 30 divided by 40, which is 3/4. Okay. One more. We're going from 1 to 2 minutes. So the change is 2 minus 1. That's 1. That's the run. And the rise is from 3 to 5. So that's a difference of 2. So 2 over 1. And there's so you're just calculating the slope between the points when you're doing the average rate of change. Okay, back to differentiability. List the x values in the graph at which the function is not differentiable. So again, for differentiability, first it has to be continuous and it has to be smooth. So everywhere it's continuous, so that's okay. But right here at this spot, there's a corner. So it's not differentiable at that spot. So at 0. Now it's saying where or list the x values in the graph for which the function is not differentiable. So you're looking for the x value. And sometimes what I'll have people say is, they'll see that 1 right next to that point. And they'll say, oh, it's not differentiable at 1. And they'll pick C, and they'll get it wrong. And they'll lose all their points because they're looking at the y value. And they want the x value. So you've got to project down to the x-axis, and it's at 0. So don't be tripped up by that. It's kind of so it's not differentiable here, but we're looking x equals 0. Okay, so again, they're kind of tripping you up. The corners where it's not differentiable are this spot and this spot. And you might see that 3 there. See that they have that as a choice, 3 and -3, but this is not the correct answer because you're looking at the X value. So you want to draw a vertical line down. The X value is -2. And you want to draw a vertical line here to the X axis. So the answer is -2 and 2. Okay. Make sure I'm sharing my screen. Here, again, it's a smooth curve except at the origin. And at that spot, at the origin, X equals 0. So that's the spot where it's not differentiable. Okay, I think you get kind of the feel for these. I'll let you do the rest of these. This one is smooth everywhere and continuous. There's no holes or breaks, so the function is differentiable at all points. Here again, there's the spot. You've got a 1 and you've got a 2 at that spot. Well, we want X equal 2, not the Y value. So here, remember, in order for it to be differentiable, it has to be continuous. And there's a break there when X equals 0. Right here, there's a break in the graph. So it's not differentiable where that break occurs. Yes, it's smooth. The curves are smooth. But remember, not only does it have to be smooth, but it has to be continuous. So that fails the continuity there. Therefore, it fails differentiability. Okay. This one, it's not differentiable here where there's a break at 0. And then also here at 3, because it's not continuous, it can't be differentiable. It has to be continuous. And there's a hole there. So it's not differentiable when X is 0 and when X is 3. All right, I did an example in my last period of this type of problem. I'll do another one because I know there's I always put a question like this on the test. There may even be 2 questions like this, where you have to find the equation of the line that's tangent to the graph at a given point. So here we have f of x is x squared minus 4, and the point is -4, 12. So when you're looking for a tangent line, you're looking for 2 things. Anytime you're looking for a line in general, you need the slope and a point. Well, we have the point. Now we just need the slope. So the slope of the tangent is the derivative of the function at that point. So the derivative is 2x, right? You bring the 2 out front, subtract 1 from 2, you get 1. The derivative of -4 is 0. And we want to know what the slope is at -4. So we plug in the x value of -4, and that's 2 times -4 or -8. So this is the slope of the tangent. And if you have y equals mx plus b, your y is 12. Your m, we just found to be -8. Your x is -4. So now we can solve for b. And so 12, we've got 32 plus b. So we're going to subtract 32 from both sides. So b is -20. That is the y-intercept for our tangent line. So the tangent line is y equals m, which is, -8, and then x minus 20. There we go. So this is our tangent line. So practice those. There are, I think, 2 problems, maybe just one, but I think possibly 2 problems on the test like that. So make sure you know how to do those. There are plenty of problems in this review to practice that idea. These are all pretty much the same sort of thing. Oh, wait, I want to go back to that. Make sure where was that? Right here. Yeah, D was the correct choice. Yeah. Oh, wait, no, not D. This was A. Okay. The other thing that I want to do, I know there are, wait a minute, I missed something. Did we go through the whole thing already? There's some problem that I missed. Oh, no, it's not on here. That's really unfortunate. Oh, shoot. I wanted to do a problem. I know there's one on the test dealing with horizontal. I don't have one on the review. Oh, I may have to fix the test. Oh, gosh, I didn't want to do that. All right, let me go over. I'm not sure what I'm going to do, but I know that there are a few problems on the test that were not covered by this review, so I want to discuss that real quick. So let me go into the homework, because I think there's some in the homework like this. I wonder if it's here. Yeah, it has to do with the horizontal tangents. But there's only one question here. Okay, so let me talk about a horizontal tangent. It says graph the following, then estimate the x values at which the tangent lines are horizontal. Okay, so and I did this in class, so it is fair to put this on the test, but I just want to point it out. There aren't any examples. I had intended to put some in the review and I failed to do that. So, so we have f of x equals x to the 4th minus 8x squared plus 2. And it says that we want to find the x values for where this has a horizontal tangent. So the important thing to remember here, a horizontal tangent exists when the derivative at a point is equal to 0. So if you want to find a horizontal tangent, then you take the derivative. So the step 1, you find the derivative, and that's 4x cubed minus 16x. Derivative of 2 is 0, so I don't. Okay, so 4x cubed minus 16x, this is the derivative, and you set it equal to 0. So step 1, find the derivative. Step 2, set the derivative equal to 0. So 0 equals 4x cubed minus 16x. And then you solve your equation. You're going to factor this particular one, you're going to factor. So we're going to take out a 4 and an x, and we're left with x squared minus 4. And then we can factor that as 4x times x plus 2 times x minus 2. This is the difference of squares. And so when you factor that, you're going to get x plus 2 times x minus 2. And the way you know that when is this equal to 0? When each one is equal to 0, or any one of them is. So either 4x is equal to 0, x plus 2 is equal to 0, or x minus 2 is equal to 0. So in this case, x equals 0. And here, x equals -2. And here, x equals 2. So these are the 3 locations for when the derivative is 0. And therefore, at 0, -2, and 2, there's a horizontal tangent. So looking at this problem, you can kind of see that here we only have one horizontal tangent, okay? The horizontal tangents occur when you've got like a maximum value or a minimum value. So you can here it's increasing and then it changes to decreasing. So at the top, the rate of change is 0. The tangent is horizontal at the peak here. But there's only one at 0, and we know that there's supposed to be one at 2 and at -2. So this is not the graph, okay? And same here. If you look, there's a horizontal tangent at the bottom there where there's a valley. There's a horizontal tangent right at this spot, but we're still missing the other 2. So we know that one's out. So it's either this one or this one. And in fact, this one is out because notice this is a polynomial. It opens down, and therefore, I'm sorry, this one opens up and this one opens down. So this is not correct. So B is the correct choice. Because the leading coefficient test, you have an even one with a positive leading coefficient, it opens up. So that is the correct one. And the location, it's -2, 0, and 2 for those horizontal tangents. Oops, wait a minute, what did I do? Did I put a point in there?
Yeah.
Oh, sorry, it's supposed to be a comma. There we go, that's better. Having a hard time seeing that, it's so small. Okay, and then let's just look at this and I'll show you. See here, you can see where the horizontal tangents are. Right here, there's a horizontal tangent right here. So at -2, you're looking at the x-axis, that's at -2, +2, and then up here at 0. So those are the tangents. If you have a constant function, so let's talk about that for a second. So y equals 7, for example. Y equals 7. Well, what is that? That is the horizontal line at a height of 7. So here's my y equals 7. Okay, it's at a height of 7. What about, when is the tangent horizontal? Well, first off, any point you pick on that line, it doesn't matter where it is. If I pick a point, the tangent line coincides with the line itself. So everywhere, no matter where I pick, the tangent is the same line. And so for the constant function to have a horizontal tangent, it has a horizontal tangent everywhere. So when you say, where does the function have a horizontal tangent? Well, for a constant function, it's everywhere. Okay, now what about if the line is not constant? Let's suppose you have a situation like this, where you just have some random line. You never have a horizontal tangent, right? Never. Why? Because any point that I pick on that line, the tangent is going to coincide with the line, and it's never horizontal, right? So with constant functions, everywhere you have a horizontal tangent. And with linear functions that are not constant, you don't have any horizontal tangents. And then otherwise, you just set the derivative equal to 0. So there are some questions on the test that deal with horizontal tangents. So check the homework. We did that. I know I covered that in class. So I wish I had put some questions on the review, but I failed to do that. Maybe I think I'm going to create a review with some questions like that, so you can practice. And I'll email you that or talk. Yeah, send an email about that. So that covers it, the test pretty well. So any questions that you have about the test, just make sure you meet at room 3000 on Tuesday during class time. So, and just bring a pencil. I'll have scratch paper and the calculators on the computer. So make sure when you come into the room that you have your cell phones put away in your bag, and then your bag is under the table when you sit down at the testing location. Okay, so have a good one. If you want to go to the testing lab to check it out, you have to do it either today or tomorrow. So just remind you of that.